Okay, today we're going to learn how to simplify radicals. And in another station today, you'll learn how to estimate radicals, the value of radicals. And that's really good because it'll teach you how to find, the approximate value of a radical when you see it. However, there are situations where you'll need to simplify radicals. And sometimes it's better to represent numbers in radical form because it's a more accurate way of displaying the value of some number. Now, the first rule to simplifying radicals is this. In this column, if you haven't already, go ahead and fill out this chart. And in this column, you should have 3 squared equals 3 times 3 equals 9. And if you go backwards, if you see the square root of 9, what this means is 3 times 3 underneath a radical equals 3, because the number that's multiplied by itself to get 9 is actually 3. So that's what the square root of 9 means. The first rule to simplifying square roots is this. Underneath a radical, if a number has a twin, then it can go outside the house. And since 3 and 3 have a twin, they have each other, they go outside the house and it just becomes 3. Now, what if you have numbers that aren't perfect squares, like the ones in these columns right here? What do? Well, I'm going to show you how to simplify these radicals. The first thing I want you to do is here in these boxes, I want you to go ahead and label each of these multiplication signs. You can either do the dot form or you can do the X for multiplication. Okay, so say like you have this square root of 45. What you're going to do is you're going to take the number underneath the radical and you're going to look for factors that 45 breaks into. 45 can be divided into 5 and 9. And 5 can't be broken down into any other factors, but 9 can. 9 can be broken down into 3 and 3. And these 3's can't be broken down into any other factors. So what I'm going to do is I'm going to go ahead and circle 5, 3, and 3, because this is the bottom of my factor chart, and these are the most simple or numbers that can be factored anymore. And they go under the radical like this. 3 times 3 times 5. And 3 times 3 times 5 equals 45. So it's just another way of writing 45. Just like we had the square root of 9 and we took out the 3, we're going to do the same thing here. Since 3 and 3 have a twin or a buddy, they can go outside the house. And so therefore 3 goes outside the house. 5, on the other hand, doesn't have a twin or doesn't have a buddy, so it's going to stay inside the house. And this is the most simple form we're going to get. Okay? Let's try square root of 50. So we have 50. We're going to break this down into its factors. It can be divided into 5 and 10. And 10 can be broken down even further into 2 and 5. And 2 and 5 can't be broken down anymore. I'm going to go ahead and circle these numbers because these are the most simple factors, and these are what are going to go under my radical or my house. And here you see we have 2 times 5 times 5. 2 doesn't have a twin, so I can't take it outside the radical, but 5 does, and it goes outside. And so we have 5 square root of 2. And that's our most simple answer. Okay? Let's try 12. 12 can be broken down into 3 and 4. 4 can be broken down into 2 and 2. And these are the most simple factors. And here we see that they're under the house. Since 2 and 2 have a buddy or a twin, they're going to go outside the house. 3 doesn't, so it's going to stay inside. And so we have 2 square root of 3. Now let's do 180. And 180 is an interesting example because we start getting more than one pair of factors that are the same. Let's do an example. 180 breaks into 2 and 90. 90 can be broken into 2 and 45. 45 can be broken down into 5 and 9. 9 can be broken down into 3 and 3. 2 is the most simple, so I'm going to circle that. 2 is the most simple. 5 can't be broken down anymore, so I'm going to go ahead and circle that, and neither can these 3's. And then if you go here, you'll see that they are all underneath the radical right here. Since 2 has a buddy, it can go outside. And so here we have a 2. Since 3 has a buddy or a twin, it can go outside also. And so the 3 goes outside. And since they're all multiplied underneath here, they're going to be multiplied outside the house too. Since 5 doesn't have a buddy, it's going to stay inside the house. And now we have to simplify this part. 2 times 3 gives us 6. And so the most simplified version of square root of 180 is 6 square root of 5. Okay? Now, I want you to go to the bottom of your paper. We're going to do one more example together, and then I want you to try the rest on your own. So here we see we have square root of 32. Now let's go ahead and do our factor tree for 32. 32 can be broken down into 2 and 16. 16 can be broken down into 2 and 8. 8 into 2 and 4. 4 into 2 and 2. I'm going to go ahead and circle my most simplified numbers. And I'm going to rewrite square root of 32 as square root of 2 times 2 times 2. Oops, I'm running out of room, but 2 times 2. Okay? These two have twins or buddies, so they're going to go outside the house. So then it's going to be 2 square root of 2 times 2 times 2. I'm going to go ahead and switch colors so it makes it a little easier to see. Okay, so now we have 2 square root of 2, and these have a twin, and they're going to go outside the house. So it becomes 2 times 2, and that's a times, square root of 2. This 2 doesn't have a buddy, so it has to stay inside the house. And since 2 times 2 can be multiplied together, the radical becomes 4 square root of 2. And that is your answer. Okay? So go ahead and try the rest of these out on your own. If you have questions, raise your hand, let me know, and I'll come by and help you out. Thanks for listening.